most probably the router you are using, the wireless router you're using at home, you have a MIPS processor. Or the printer you have, printer, scanner, whatever you have at your home, that might be a MIPS processor. If you have a smart television or smart refrigerator or an oven, that might also have a MIPS processor. All right. So nowadays, most of our devices are smart because it has integrated microprocessor, it has integrated system and operating system and the program. So those kind of smart devices, most of the smart devices, they're using this kind of MIPS processor. Right. So do not think that it is not necessary to know. So in future, maybe if you want to do coding on, let's say, a new device, or let's say you have a smart embedded system which you need to program, you need to do control the things or all the sensors, then you can use this kind of MIPS processor. Although we are not going to, implement or build anything by using this MIPS processor, but at least if you have an idea that these are the separate types of processing, completely different types of processor where you are coding in the computer, so it will help. It will help you a lot. All right. By the way, to be honest, before you're doing this course, have you ever think about it that your mobile processor is one type, or your router has one processor, or maybe your computer processor? What did you think previously, that all the processors are same, or you know that previously that those are different types of processor? Did you know that these are the different types of processor? Or did you ever think about this? Anyone?
No, sir.
Yes, sir.
Oh, so if you think, okay, someone say yes, someone say no. So if you're thinking that it is a different types of processor, what was your thinking? What was your thinking that the processor inside a smart television, or the processor inside a microwave oven, or the processor inside your tablet, or in your PC or laptop, how they are different?
They are actually measured by their capabilities and used by them. Normally, if we just think about a tablet doesn't need a 3.8 or 4.2 gigahertz processing unit, because it doesn't have that kind of power to process all the data. And that much processing power needs more electricity, so tablet don't use that kind of processor. They will go much rather the small processors to complete the data and small data tasks. So tablet processor and PC processor will be different from one another. And mobile goes on the same direction. It needs to save the electricity, and the processing power needs to be much smaller than the bigger scale that we use on the PC.
Most of you are saying that it is correct. Let me just correct in one thing, that nowadays your tablet processor or the mobile processor, they are very powerful, by the way, very powerful. Most of them now, if you buy a new device right now, let's say I bought one Samsung A52, that one has octa-core processor, and it is 2-point-something gigahertz. So not that much slow, whatever we are thinking about our processor, our processor in the computer. Let me give you another example. I have another tablet. It's a very powerful tablet, which is Samsung Galaxy S7. All right. So that Galaxy Samsung S7, with that tablet, I can do everything, almost everything I can do in this computer or my laptop. Same thing I can do much more faster way with my tablet, because that tablet has a very powerful processor as well. And not only processor, all the equipment. So nowadays, I think, our mobile device they are much more powerful enough that you can do on your mobile phone or same as the computer. For example, what you do in your PC, you do some word processing, right? You do watch the video, you do the classes, you do the online meeting, you do everything, right? So you can do the same thing in your mobile phone as well. Most of you are doing it right now. So you just think about the difference. Then why we need a bigger device like the PC or like laptop? Why don't you always use that? Why I always say that do not use the mobile phone if it is not absolutely necessary. Try to use the laptop or PC. There is a reason. There is a reason that why we have different devices actually depends on your requirements. It totally depends on your requirements. For example, let's say you want to run a very powerful script, let's say MATLAB, okay, MATLAB, and you want to run it in your, coding want to run into the laptop. Let's consider your desktop has 10th generation Intel Core i5 processor. Your laptop also have Intel Core i5 clock, same 3.5 gigahertz. But do you think that both of the processors are same? Whatever you are using in the desktop and whatever you are using in the laptop, the processor itself, let's say Intel Core i5, 10th generation, the microprocessor, what you are using, is it the same? Do you think that it is same for the or same microprocessor is in the desktop and same in the laptop? Not really. Microprocessor has two different versions. Same thing, same model, but two different versions. One is for the desktop, another one is for the laptop. Because the laptop has very small size, compact one. But in the desktop, you have a lot of space. You have full size. The size of the transistor, the size of the cooling materials, the size of the package is full size whenever you are using in a desktop. Same processor, same model of the processor, where they build it for the laptop. Same amount of register, but the size is compact. So whenever your size is compact, obviously you need less amount of energy. Same as your mobile phone, same as your tablet as well. Okay, although they can do a lot of tasks. They can do a lot of tasks. So, and some of the tablets, for example, my one, it has a desktop mode. It has a desktop mode. So if I use or convert into the desktop mode, it will be completely one PC from tablet, like this, whatever we are using. So nowadays is actually all of the devices are compatible to each other. So that's why I think if you remember, whenever we learn about the RISC types of processor, do you remember that one of the types of the RISC processor is using in the Linux workstation and also in the supercomputer, right? RISC types of processor. Can you remember? Can you remember the example of the RISC types of processor and CISC types of processor? Most of the time, CISC types of processor, these are Intel or Motorola processor, right? But in the RISC types of processor, we are using like smaller devices processor, but there are some exceptions. RISC types of processor, which is some of the supercomputer, they are using RISC types of processor. And now, although we are saying that the smaller devices using RISC types of processor, but nowadays may not be this the correct statement, because some of the bigger processor, they also try to use this RISC types of processor. Because this is easy, this is not that much, requires that much power. It is less complex, all right? So it is much more better. So one of the example of those kind of processor is MIPS processor. We need to know whenever we go or whatever we do or wherever we do the coding, we also need to know our system very well. That's why we also must know that we have a different sets of processor, and this might have some different other features. So in this chapter number 12 and 13, we are going to discuss about different features, slightly different architecture of RISC types of processor. And we know that these types of processor, we have so many different types. We are just choosing one type, which is the MIPS processor. Okay, it's widely used and so popular as well nowadays as well. Fine. So those are the all, introductory discussion to just let you know that why we are still using and what is the importance of the MIPS processor or the RISC processor. Everything is written here in the introduction. You can read it from here, no problem, all the history and everything. Evaluation, not necessary at all. So let us go directly to this one, 12.3, design principles. RISC design principles. Previously, whenever we have discussed about the CSC types of processor, right? CSC types of processor. So those CSC types of processor we are using like Intel processor, and we also already discussed about chapter number 2 and 3 about the architecture, the memory architecture, the addressing mode, and the types of the register, and so many things we have discussed. Similar way, we are also need to know what is the structure of our RISC types of processor. Okay, RISC types of processor. So there is a picture. Look at these two pictures. Thousands of emails actually come every day to me. Really annoying. All right, so look at these two pictures. You will have an idea that what is the CSC processor, what we have discussed earlier, and what is the RISC types of processor, what we are going to discuss right now. ISA means instruction set architecture. ISA. Somewhere written. Instruction set architecture. ISA. So ISA means instruction set architecture. That means the architecture of the processor. How does it work? Okay, so this is the CSC types of processor, and that is the RISC types of processor. This is the Pentium processor, left side. This is the processor which you are using in your wireless router, modem, refrigerator, printer, scanner, those kind of small devices. Some of the PC, as I said, some of the PC might also have this one, which is Linux based, and some of the supercomputer, they also use this kind of microprocessor. All right, so what is the difference? The difference is whenever you write IS instruction, that level, that means this is actually the coding level or the structure level, instruction set architecture. So whenever you write any code into the CSC processor, right, it will be controlled, or it will be modified, or it will be divided into microprogram first, and then it goes to the hardware level. All right, I will explain. And on the other hand, in the RISC processor, whatever coding you are going to do, it is so simple, and it directly implemented in the hardware. That is the two differences we have, the CSC and RISC implementation. So now the question is, what is the microcontroller? I mean, not microcontroller, I mean microprogram. I hope you remember, whenever we do coding in CSC types of processor, right? We said that RISC types of processor coding are really complex one, right? Why it is a complex one? Can you remember? 6 types of processor. We said that it's a complex one. It's a short program, but it is a complex program. Can you remember why? CSC.
Because in one line,
exactly,
there is a lot of instructions.
Exactly. Very good. Yes. Yes, correct. Whenever you write the code in 6 types of processor, for example, in your Pentium processor, if you just write add 2 numbers, then it will add 2 numbers. But behind this addition, there are so many other, small coding or lower level coding is working behind that code. But we don't need to know that. We just need to write add 2 number. That's it. Rest of the task will be done by the processor. So the rest of the task, whenever you say that one line of code is actually combination of all other code as well. So one code is divided into small parts. All right. So this microprogram is actually at those parts. That's why it's called microprogram. All right. That means, for example, you want to add two numbers. So you write add one register or one memory address, comma, another memory address. Right. Source and destination. So whenever you write this code, the processor will then, divide this addition or divide this instruction into several parts. For example, you have to go to that memory location and fetch the data and put it into the register. And then you go to the second location of the operands and fetch the data and come back to the processor and put it into the register. And then you add together. And then after adding, you store the result into the specific memory location. So all these tasks are actually the microprogram, the smaller program, which creates one bigger program, which is add two numbers. All right. So that's how the CISC processor works. That's why whenever you write the code, it's not directly go to the hardware or directly not implemented to the hardware. So there is a control unit, which is called microprogram control unit. So they divide those tasks, do task one by one, and then put it into the hardware. Or on the other hand, in the RISC types of processor, you actually cannot write directly just add two numbers, right? You have to move those numbers into the registers, right? Into the registers, and then after doing having the data into the register, and then you do the addition. And after the addition, the result will be stored again into the memory location if you want, right? So you have to write separately all of them, and each of the instruction can be executed in one single clock cycle of the processor. So that's why there is no need for any middle software or middle unit which can convert the coding. So it is quite enough that each of the coding can directly run by the hardware or implemented into the hardware. It's a long story, big story, but I hope you understand. I explained you that much so that you can understand. If you remember, try to remember about the CISC and RISC processor, then it will be much easier to visualize. You just need to visualize that how it's working. Whenever you do write any coding or whenever you do instruction to your system, if it is a CISC processor, for example, your PC actually doing in this way. But whenever you do the same instruction to your mobile phone, it will do in that way. Nowadays, many of the microprocessors try to shift from this to here to there. That means they really don't want to do this coding or to do this architecture that much complex. That's why they're willing to come or shift from the 6 types of architecture to the RISC types of architecture, because it is simple, it is easier to implement. So why need to do the more complex one? This was using long before, because we have very less amount of memory. But nowadays we don't have less amount of memory. So we can afford so many coding for just one instruction. Right, that is the difference. Okay, fine. Why we need to know this right now? Because we are now thinking about the new types of processor. The previous types of processor we are using previously, the Pentium processor. This one, mid-size processor, slightly different. So we need to know the difference. Remember, if you know the architecture of a processor, it will be much easier for you to control it. Right. For example, if you want to drive a car, if you don't know your car properly, if you don't know the features of the car properly, it is sometimes impossible to drive it. If you don't know your system properly, for example, your computer, then how you're going to use it properly? You cannot use it properly. So to use them properly, you know your system very well first. You need to know the architecture, the features and everything first. And then you have to use them. I still can remember. I just have in my mind that when I give my driving license exam in Malaysia, it was actually how many exams I have given. One for the eye test, another for the theory test, written. Third one is to know about my car. All the parts I have to explain that this is this is that, everything inside and outside of the car. Third test. Fourth test is I need to drive inside a circuit area. So in a premises, so there is a roundabout, there is a bumpy area, there is some very high space. So there is third test. Fifth test is I have to go to the original road, and my instructor, my examiner was just behind my side. So I have given 5 tests just to get one driving license. Why I'm saying this one? Because if you don't know the reason behind this, why I need to learn all the components, I need to learn literally, I have to learn physically, theoretically, and practically that what is the name of this part and why we need this in this car, what is the feature, what is the responsibility of this device, all the devices of the car, most of the parts, common parts. There are so many parts, but most of the common parts inside the car and outside the car. Why it is required to driving a car? Because the same reason, if you don't know your car properly, you cannot drive it properly. That means you are not eligible to, or you are not, good enough to drive, and you don't get not good enough to get a license. Luckily, I got the license for the first time, which is very good. Anyway, same as your system as well. If you don't know your computer very well, if you don't know your system very well, if you don't know the architecture of your processor, how are you going to use them? Not possible. Okay, so that's why we need to know our structure very well. Some of the courses I know, that's why I changed this assembly language, and not me, our department, changed this one from the previous types of assembly language to this assembly language course. Although this will be the last time the assembly language course will be offered, hopefully, because from the next year, there will be no assembly language course separately. It will be the microprocessor course and the assembly language together. Anyway, that is a different story. But previous courses, that is also very good. But previous courses, when I saw the course outline, it's all about just like boarding 8086, coding, register name, coding. So what the students actually doing previously, just memorize without understanding any single character. They just memorize. And I'm sure if this is your second time course, you can ask yourself. And whenever they memorize, they actually don't know why they are reading this one, why they are studying this one. They're actually not sure that why you are studying, and in the future, where you are going to use this assembly language. Because you don't understand anything. You don't know where you're going to use them. You will just blindly memorize. That's why whenever we are talking about the alumni, so many of them say that the assembly language course should not be or should be removed because it is not necessary. That is an incorrect statement, that assembly language is not necessary. It is necessary if you know how to use it. It is necessary if you know where to use it. So that's why we propose, we try, we're doing work hard, very hard, that we need to shift from the previous course to here. And now we are trying. I know that it is really the same, that you are going to memorize and you don't understand anything, but at least that I am trying to give you, not me, all of the faculty that are doing the same syllabus, we are trying to at least giving you some idea that you need to know about this assembly language course, assembly language to do or do this kind of coding. Maybe in the future, whenever you want to do this kind of coding, then you might need it, right? So, and it is true, and it will be true, and it should be true for all other courses. You need to know why you are doing this. If you know why you are doing this, then it's fine, no problem. But if you don't know why you are doing this, then it is not possible that you are going to use it anytime. Okay, so please, my request is do not blindly memorize this course. I know it is boring course. I know it is difficult. I know you have very bad results, but I mean, considering all of this thing, but still try to understand, try to, understand that why you are using this one and where you can use it in the future. Remember, this will be very helpful for you, not anything else. Anyway, so that is the comparison between these two. We are going to use this RISC processor, and I can tell you that this RISC implementation will be the only one in the very near future. Nobody is going to use this RISC processor maybe in the near future. Maybe there will be another type of architecture, but this one is very old. So in the future, let's say after 5 years, after 10 years, you will see all of the microprocessor will be this type because this is simple. All right. So let us discuss. There are not five, including the other one. There are six. There are six principles, or there are six features we have in this RISC types of microprocessor. By the way, any question? No? No question?
No, sir.
When I actually when I'm talking like continuously, what actually you do? Do you actually listen to me, or you just, okay, it doesn't matter. You just listen to me when I call your name for that illness. Yes, sir, yes, sir, yes, sir. Thank you very much, sir. See you tomorrow, lovers. That's you are listening, properly, right? Whenever. Thank you very much. Thank you very much. At least one of you actually listening to me, because I don't actually feel, because I don't know that where you are listening or not. Yesterday we have a meeting with. Let me share some experience. It will be better. I think it will be very interesting for you as well, because at that time I was also like you, so I was listening the lecture yesterday. So then actually I was feeling the same feeling what actually you feel right now. So it was an online seminar. It's a government seminar. So it was related to the quality assurance. Okay, some of the experts from Malaysia, they come here. Not come here, online. We have a session and question and answer and so many things. I actually like one slide, not only one, but 3 slides. So one of them, she said she's an expert of quality assurance. She actually quote 2 sentences from Aristotle. Okay, it is not boring. Listen first. There are 2 quotations in 2 sentences from Aristotle. They say that you are, okay, the quotation is, we are what we are doing regularly. Think about it. We are, that means, for example, I am what I am doing it regularly. You are what you are doing it regularly. So think about it. Ask yourself, which thing you are actually doing it regularly. If you do regularly playing, that means you are a player. If you do study regularly, that means you are a very good student. If you teach regularly, then you are a teacher. If you research regularly, then you are a researcher. If you do some other tasks, then you do that one. You are that one. So it's a very nice one, understandable, that we are what we are doing regularly. If you do regularly study, very good. You have a good profession, student or teacher or researcher. If you do nothing, Facebooking or nothing, or just spend your time for doing something else, then you are not a student, you are not a researcher, you are not a good human being if you're not doing the right thing. So it's a nice quotation. I didn't know that before, but yesterday I heard it. So that means what you are doing it regularly. Think about it. Next one is from Aristotle, from yesterday's slide, that excellence, all right? Excellence is not an act, it's a habit. Think about it again. Excellence is not an act, it's a habit. It's a habit. Let me give you an example. Think about Mr. Saqib Al-Hasan. Today we have a match, 4:30 maybe. Why do you think that Mr. Saqib Al-Hasan is much better than everyone else? Why don't you think that Mr. Shomo Sarkar is not same as Mr. Saqib Al-Hasan? Maybe the reason is Mr. Shomo Sarkar is actually playing some very good innings one time, two times. That is an act. But Mr. Saqib Al-Hasan do a very good bowling and batting regularly, every single day, or almost regularly. That is the difference. That's why he is excellent. That's why Mr. Shomo Sarkar is not excellent. That is the example that excellence is not an act. That means if you play just one innings in 1 year, it is not an excellent one. It is nothing. But on the other side, Mr. Saqib Al-Hasan play very good innings almost every month, every week, every time, because it is his habit. That is the excellence. So excellence is actually not a single act or the random act. It's actually a habit. And this habit comes when you do it regularly. When you do it regularly, then it becomes a habit. And that habit can gives you that excellence. Although it's a boring talking, but it is really important. For example, you want to do something, right? You want to be successful as a programmer, as a student, as a player, whatever you want, as a graphics designer, as a website developer, whatever you want, right? You have to do it regularly, a long time. Only then, whenever you do it regularly, long time, and then you actually be the excellent person, or you will be the expert person on that field. So let's say, for example, you want to be a website developer. Do it every day, do it regularly, every day, again and again and again and again. Let's say 1 year, 2 years, 3 years, 4 years, 5 years. Then after 5 years, whatever you do after 5 years, it will be very good product. Because it is an excellent job, because it's your habit right now. There is another thing, like it says 10,000 hours rule, 10,000 hours rule. Note it down, and you can do it in a Google search. Just Google search is 10,000 hours. 10,000 hours. What is it? Theory. So why I'm saying this one, because I know this topic is very difficult and really boring, and you don't like it. You just need to do it only for the marks. But if you think about it, that you do it again and again and again, then it should not be actually that much difficult. Same as me, when I first take this course, it was really difficult for me as well, because I forget everything. It was like 15, 16 years ago. So, but I read it regularly. Last night, I also read it, this chapter, until 2 o'clock in the morning, because I need to read it every day. So you need to make a habit like this. So if you read it not every day, regularly, much better for you as well. Trust me, it works. If you really want to do something, if you just follow this way, it really works for me. And as I said, it's from the Mr. Aristotle, so it must be right. Anyway, so I think there's an interesting thing to share. That's why I shared. Anyway, so let us discuss one by one. There are 6 principles. There are 6 principles in list types of processor. First of all, the simple operation, of course, we already have discussed that it is simple. If you compare these two things like CSC and RISC, it is simpler than this one, right? So that's what you have, they have discussed here, see figure 12.1, this figure. So we know that it's a simple operation. Register to register operation. So we also know that the CIS types of processor is memory, they use the memory, and the RISC types of processor, they're using like register, right? So in most of the task in these types of RISC processor, they're using the register to register operation. There are very few, right? There are very few operations like some of the load and store architecture. They need to access the memory, but the rest of the task they have written. The rest of the operation works on a register to register basis. It is written here in the book. RISC processor allow only special load and store operation to access the memory, and the rest of the operations work on a register to register basis. That means we know that it is in the 6 RISC types of processor, most of the tasks are register to register. That's why it is faster. That's why it is much more better to use it. Okay. Another one is the simple addressing mode. Okay. I hope you remember there are 4 addressing modes we have discussed in chapter number 4 for the Pentium processor. Although there are not 4 addressing modes, there are several other addressing modes. So we didn't discuss this one in chapter number 6 maybe. So they also have some other very complex addressing mode, but in the CISC processor. But here in the RISC processor, they are very simple because they are using only the register. Okay, and especially in this MIPS types of processor, you can see that is written MIPS supports simple register indirect addressing mode. I hope you remember that in the chapter number 4 we have discussed direct addressing mode, indirect addressing mode, which they have used it into the memory, main memory. But here in the MIPS processor, they're using register in the indirect addressing mode, not the main memory, because they are using register. Right, so MIPS processor using simple addressing mode, and the MIPS or MIPS processor, they support register indirect addressing mode. Okay, so that is the third feature. Fourth feature is the large number of register. Of course, they have large number of register because everything you are going to do by using the register, most of the tasks you are going to do by register to register. There are very few tasks you're actually using the main memory, right? So that's why you need larger register, because you have a lot of tasks to do, because most of the tasks is by register. That's why the size of the register is bigger comparatively. If you compare with the 6 types of processor, disk processor, they have larger size, and the number of the register is more compared to the 6 processor. So they have large number of register. Fine. Fifth one, it is also, we already know that size of the instruction. I hope you remember whenever we discuss about the difference between CISC and RISC processor, right? So CISC processor, whenever you convert your CISC instruction into the machine language, different instruction, the size or length is actually different in the CISC processor. But if you think about the RISC processor, these types of processor, whatever instruction you write, all the length of the instruction, whenever you convert into the machine language, they are all same size. That is a very good feature. That is a very good feature for this MIPS types of processor or RISC types of processor. We will see very soon that in the MIPS processor, like this one, let me show you the picture. Oh, it is in the next chapter. It is in the next chapter, not in this chapter. We have 3 different types of addressing modes. So with those addressing modes, we will see that the size of the instruction, they are all same. Okay, we will discuss into the next chapter, chapter number 13. So this is the fifth uh, fifth features we have. That means the fixed length and simple instruction format, of course. Those are the 5 features, basic 5 features. They explain another feature which they call other features, which is they call Harvard architecture. This is, I think this Harvard architecture was invented by the Harvard University student. That's why, or Harvard University researcher, that's why they name after the university. That's called Harvard architecture. In this architecture, that means this is an architecture, they use RISC uses this architecture for their processor. So what is it actually? In these types of architecture, the data and the instruction, they are actually considered in a separate location and in the separate way they implement and they use it. Okay, that's why they have said this one, Harvard architecture, which allows independent path for data and instruction. However, I will show you the simplest one. That means this requires 2 cache memories, one for data and one for the other instruction. That means this is one kind of architecture of the implementation of the RISC processor, where you have the data and the instruction, that means the code, they are separately located, all right? And you consider them separately, the data segment and the code segment as well. Okay. So these are the 6 features we have for this. That will be the last topic. So 6 design principles or features we have of this RISC types of processor. Okay, and we know that MIPS is one type of RISC processor. That's why it is also the characteristics of the MIPS processor. Let me just revise once again, which is first features is it's a simple operation, because it's very simple. If you compare these two, it's simple. There is no microprogram control. It's directly implemented by the hardware. Next one, we have used register to register operation, because we have very few, because some of the very special load and store architecture, load and store operations we have, which uses the main memory. Other than that, all of them are register to register. All right. Third one is a simple addressing mode. Not like the previous Pentium processor, we have 4, 5, 6 different types of addressing mode. Here, generally, we have very few amount of addressing mode. Generally, we have 3. We will discuss it in the next chapter, that what are those 3. But generally, the MIPS processor supports register indirect addressing mode. MIPS processor, it's a simple one compared to the Intel processor. We have the fourth one, is the large number of the register, because this types of processor uses only the register for their most of the task. That's why the number of the register is higher compared to the other types of processor. That is the fourth one. Fifth one is the fixed length of the instruction. Whatever you write the instruction in these types of processor, the length of the machine language code will be the same. Where the 6 processor, they have different length for the different types of coding. Okay, that is the fifth one. And sixth one is they're using or they're implementing the Harvard architecture, where the data and the instruction, they are separately considered. And that's why they also have separately as well for the data and for the instruction. So these are the 6 features, common features we have in RISC types of processor. Fine. Any question? Is it too difficult, by the way? Most of the part we already know, right? Please say something, yes, no, or not good, or you don't understand, or something else.
So not difficult, kind of confusing, but I think starting will clear that up. But sir, I have an extra question.
Yeah.
So yesterday you talked about IEEE, but I had a question that I couldn't ask yesterday. if I take any kind of research paper that someone has published, can I put those research on a blog? I mean, for the research or any kind of news preparation?
No, without the permission,
Okay,
because it is totally copyright transferred to the IEEE. So without having
yes, sir. That's why I'm really confused.
legally, you cannot. You cannot. For example, I am author of 4 IEEE papers. I cannot upload my papers to somewhere which is where I can publish online. I can store it into my repository, which is for the academic purpose, like my university. I can upload into the repository of the university or the library, but not anywhere else, because still it is my paper. I cannot do that because I already transferred the rights to IEEE. So they will handle it or they will publish it, not me. It is a copyright issue. Even my thesis, my PhD thesis, I already transfer the copyright to my university. It is the property of the university now, not me. I can use it, but I cannot publish it anywhere. So it's a copyright issue. Anyway, any other question? No? So please read it from the book. The book is written very nicely, especially this one, the slides I have shown. We have only 1 minute left. So the slide I have shown for this chapter, they have just written the name. I mean, just the name, no explanation.